Let's hit these final trends before they go out of style. That's right, today we're wrapping up periodic table trends. Hit the theme.
Ain't nothing but a chem thing, baby. Two flipped out teachers going crazy. Lancaster is a district that pays me. Unbreakable, so please don't try to break this. But back to the lecture at hand.
Hello and welcome to another episode of SchuFu coming at you. I'm your host Fu, and with me as always is Shu.
Shu know it.
So on the previous episode, we talked about the three major trends of the periodic table being electronegativity, first ionization energy, and atomic radius.
And today we're going to continue with a few more trends, but we're also going to use those previous trends to kind of build on that and talk about the activities of metals and nonmetals. Let's get started. Periodic trends, the return, a lesson from the periodic table unit. Miscellaneous trends. Let's begin with density. Density tends to increase down a group. It increases, then decreases across a period, so it's not really a consistent trend there. Now, it is worth noting that we're looking at the solid structure of many atoms, not just individual atoms like we did for the previous trends.
Some more miscellaneous trends, melting point and boiling points. It's similar to density, but it's even less consistent. So taking a look at our image here, the periodic table, the redder the element is, the higher the melting point.
You may be wondering how you're going to remember those previous trends. Well, the good news is you have table S to look up the actual values. In fact, the same applies to the three trends from the previous lesson.
One of the beautiful things about having your chemistry reference tables is having table S. So if you look at the titles of the columns on table S, we've got first ionization energy, electronegativity, and atomic radius. Those are the trends we discussed in the previous lesson. And the very inconsistent trends of melting point, boiling point, and density are also labeled on table S. So you don't have to worry about memorizing these trends.
Say yes
to table S.
You try number one. Which has the greater density, beryllium or boron? Write down both values with units. Which has the lower melting point, fluorine or neon? Write down both values with units.
Thermal and electrical conductivity. We can't look up these values because they're not on table S. We at least know that as we move across the period and go from metals to a metalloid to a nonmetal, conductivity decreases. And this is because remember that metals are good conductors of heat and electricity and nonmetals are poor conductors of heat and electricity. So then it also increases as you go down a group. And I think this is best illustrated in groups that have nonmetals at the top, like carbon or nitrogen. If you go at the top, you have nonmetals to metalloids to metals.
Metal and nonmetal activity. Let's begin with active metals. We know that metals tend to lose electrons, thus they have weak attractions. Down a group, the weakest attractions are at the bottom.
This is because as you go down a group, you have more PELs. So those valence electrons are very far from the nucleus, so the attraction is weaker.
Across a period, the weakest attractions are at the left.
Now the important thing to remember in terms of structure for a period is the atomic number or the number of protons. So as we go back towards the left, we have the least number of protons, therefore the attraction for those electrons is the weakest.
And if we put those two things together, going down a group and across a period, the most active metal or the most metallic element on the periodic table is francium.
Active nonmetals. We know that nonmetals tend to gain electrons. Thus, they have strong attractions. Down a group, the strongest attractions are actually at the top.
Now at the top, we have the fewest number of PELs and shielding electrons, and the electrons are closer to the nucleus, which means we would have strong attractions.
Across a period, the strongest attractions are at the right.
Going across a period, our energy level and shielding electrons stay the same, but we have a higher nuclear charge over to the right, meaning that we have higher attractions.
But group 18 elements are not reactive. The noble gases, they don't react, so we don't consider them a part of this trend. The most active nonmetal, most non-metallic element on the periodic table is fluorine.
Explaining these activities. Anytime you are asked to compare elements, use the following format. You kind of have a recipe you're going to follow when answering these types of questions. Number one, determine if you are comparing elements in a group or period. If we're in a group, we're gonna discuss changes in energy levels or shielding electrons. If we're in a period, we're gonna discuss changes in nuclear charge. Number 2, explain how the above factors affect the attractions between the nucleus and electrons. And they're gonna put everything together at the end. You're gonna explain that trend in terms of metallic, likely to lose electrons, or non-metallic, likely to gain electrons. Let's do an example. Are you ready, Fu?
I am.
All right, which of the following is a more active metal, RB or CS? All right, let's take a look at the periodic table.
Okay.
And find RB and CS.
Actually, they're both there in group 1.
All right, so this is a group trend we're talking about, not a period trend. So going back to the previous slide, let's use the same format as shown in the previous slide, number 1.
Okay.
All right, so we're gonna talk about a group trend. So let's write that down, that RB and CS are in the same group.
Okay, RB and CS, same group.
All right, so Fu, what do we have to talk about when discussing group trends?
Either PELs or shielding electrons, right?
All right, well, let's talk about both. So how would you compare the two of them?
All right, so CS is lower than RB, so it has more PELs and more shielding electrons.
Very good, let's note that also in number 1. All right, so now we've talked about the atomic structure part of things. We're gonna go to number 2. We wanna talk about attraction. So again, you said that CS has more PELs and shielding. What would that do to its attractions between the nucleus and electrons?
Okay, so since CS has more PELs than RB, it means that it's further from the nucleus, those outermost, those valence electrons.
Good.
It also has more shielding electrons, which means that the attraction overall would be weaker from the nucleus to those outer electrons.
Very good, let's note that for number 2. All right, now this is where we kind of bring everything together. The question asks, which is the more active metal? Now, active metals, what are they more likely to do? Lose electrons or gain them?
Right. So metals tend to lose electrons, non-metals tend to gain electrons, and we're talking about group 1 here, the alkali metals, so they tend to lose electrons.
Right, good. So if we're gonna establish which is the more active metal based on 1 and 2, what do you think we're gonna say?
Well, since CS has more PELs, that meant that it has a weaker attraction. And if it has a weaker attraction, that must mean that those electrons can be lost quicker.
Good.
Makes sense?
Yeah.
So CS is more likely to lose electrons.
Good. And that would make it the more active metal. You try number 2. Which of the following is more metallic, K or Ca? Be sure to use the procedure that we used in the example, 1, 2, and 3.
All right, let's do another example here. Shu, are you ready?
I'm ready.
All right, which of the following is more non-metallic, O or F? So we need to look up these elements on our periodic table, so let's go there.
All right, so I see that O and F are in the same period.
Good, all right, so now that we know that, we can kind of do our recipe here, 1, 2, and 3. So let's start with number 1.
All right, so we're gonna say O and F are in the same period.
Good, and what type of structure do we want to focus on when elements are in the same period?
Well, you do remember that the energy levels and the shielding electrons are the same, so the only important factor left would be the atomic number of nuclear charge.
Perfect, all right, so let's note that.
All right, so since F has a greater atomic number, F has a greater nuclear charge.
All right, so for number 2 then, how are we going to explain the attraction in terms of the structure?
Okay, so F has a greater nuclear charge, so there's a greater pull inward from the nucleus to the electron, so I would say that F is the one that has stronger attractions compared to oxygen.
All right, so using 1 and 2, let's kind of tie it all together for number 3 here. So how are we gonna answer this question?
All right, well, we want the one that's more non-metallic, and I have to remember that metals lose electrons, but non-metals gain. So if I'm looking for something that's more non-metallic, I want to have the one that's more likely to gain electrons. So based on the fact that F has a greater nuclear charge and stronger attractions, I think that means it's more likely to gain electrons, right?
That's correct.
All right.
Good. You try number 3. Which of the following is a more active non-metal, Br or I? Please use the same setup as we have done in the previous examples. Well, that's going to do it for the unit on the periodic table.
It's been emotional.
Today's episode is brought to you by
Toe Tune Slipper Speakers, the ultimate toe jam. It's like having a DJ in your slippers. Winner of the Most Comfy Speakers Award from Woof and Tweet Weekly.
But we never off, always on to the break of dawn. SCIENCE in the hall they call S-Wing. You know we never wear a tie like my homies, boys to men. It's so hard to say goodbye.
Like this, that, and this, and it's like that, and like this, and like that, and it's like this.
You're going in low power mode.
Plug and chill to the next episode.